Hi students, good evening and welcome you all to my session on KVPY examination on thermal physics. Alright, students, I'm so happy to see you here on a Friday evening. Alright, looks it like how keen you are for these examination. Okay, my name is Sumit Kundu. I am a BTech graduate from IIT Bombay and I passed out in the year 2007, so it's been like almost 11 years that I have passed out. In this long journey of mine, I have been into the corporate sector as well. Worked into an IT company and then started my own company in Bombay, which was later acquired by Naukri.com. And since 2011, students, I have been into full-time teaching and multiple batches of JEE and mains and advanced that we have taught and scholarship examinations also. And it gives a great sense of satisfaction to see all these students coming out with such flying colors and ranks in their examination. Okay. Now, students here in Vedantu, which is altogether such a beautiful concept, we connected to our students through WhatsApp groups. All right. And today's session, I have kind of designed in such a way that because a lot of queries were coming, sir, what is the pattern and how we should prepare, what are the books to be followed and things like that. So I kind of took those things also into consideration while preparing for today's session. Okay, so I right away get started. In the beginning, I am going to talk to you a little bit about the pattern of the examination and how is the examinations being conducted. And after that particular thing, we'll start off with thermal physics. Thermal physics as such is a very big thing. It's a huge concept. Okay, it's a very voluminous topic, but again, it's a very scoring topic, students. That's the reason why we want to focus and stress on that. Okay, because you see, today is what, first week of September. All right. Now, being first week of September, we just have what? How many months left? 2 months left. All right, students. Now, 2 months left, and we cannot study everything probably, right? So we need to make wise decision as to which are the topics to be completed, which is going to help you score in your KVPY examination. All right. First thing is that. Second thing, why is this going to be very beneficial for you? Now, this year, all of you know that your JEE mains, yes, right. Some of you guessed it right. That your JEE mains in the month is in the month of January. Okay. Now, being in the month of January, if you are having a fast track revision of your syllabus till that time, okay, that is by the month of November. So you are well ahead of the other students, all right, who are preparing for these examinations for the JEE mains, appearing for the JEE mains. You're well ahead of them and well prepared. Okay. Second thing, I've kind of noticed when I was appearing for my JEE mains and advanced in the year 2003. During those times, we didn't have many students appearing for these KVPY examinations. It is just lately that I have seen that the trend is changing. Before your JEE mains. So let's get started, students. Are you excited? Me too. I am also excited. Chalo, let's get started then. About the KVPY examination, it is a national program of fellowship in basic sciences and it is being conducted by the IISc. It's a government body organized and it is going to get for these kind of courses, they grant you a monthly fellowship. So it's all the research related field. Okay, of 5,000 per month and a yearly grant of 20,000 rupees. Okay, now students, that is for the first 3 years. That is 1 to 3 years, you get 5,000 rupees. Now you're kind of extending your research and like you're pursuing your education forward for the fourth and the fifth year. Then your monthly fellowship actually increases to 8,000 rupees per month, and your yearly grant goes up to 28,000. All right, this kind of goes up to 28,000. Okay. Now, students, what is the eligibility? Who all can appear for these examinations? The 11th standard students, that's known as your SA. The 12th standard students, that is called as your SX. And also, if you're in your first year of graduation, even then you can do it. And it is under the heading of SP. All right. Students, it's an aptitude. It's like, the selection process is such that it has an aptitude test which consists of 75% okay weightage for your selection, and you have an interview which has a weightage of 25%. All right. So this is primarily the process of getting selected. It's got a online as well as a offline mode. Now you see everything is turning online. So but still we have offline to this particular thing as well. And the total number of marks, excuse me please. The total number of marks in this is actually 100, and it is divided into two parts, as you would say. I'll just give you a short breakup of this. The ones who are there for your essay, my dear students, for them, the paper is divided into 4 sections. That is your physics, chemistry, maths, and bio, and all the sections are compulsory. The first part, each question carries 1 mark. So that is like 15 into 4, 60, 60 into 1, total 60 marks in the first part. And in the part 2, you have got like, 5 into 4, that is 20. And each question carries like 2 marks. So that is like 20 into 2, that is 40. All right. So students, 60, 40, that's like total of 100 marks. Okay. However, for the SX and the SB, we have a certain amount of liberty. Okay, that is like, in the choice. That is your physics, chemistry, maths, bio. Out of these 4 sections, you can choose any 3. So you can opt for PCM, or you can opt for like, your PCB. And that is from the first part. Each question again carries like 1 mark. And from the part 2, you can select any 2, whether physics or chemistry, or like, chemistry or maths, or physics or maths, whatever is your choice. So that gives you like, 60 out here, 20, 20, 20, 60 out here, and 10, 20 into 2, that's like again 40. So total paper is of 100 marks. All right, students. So this is going to be very much and very much your pattern like, and there is the negative marking of 1/4. Okay. So that is a sad part, but again, for a competitive examination, it is very, very important, as you would all know it. Okay, guys. So now, kind of let's get started with today's session on thermal physics. Now, students, thermal physics is like huge. Okay, but again, based on my analysis of previous year's question paper of your KVPY, I have decisively come to a conclusion that there is one set of questions which are coming repeatedly over the years, and your concepts, if it is developed for that particular part, then by default you are going to get that question right. Okay, so such kind of choices, making such kind of choices in the examination, that is what is important. All right, and rest, everything will fall into place. Okay, so here I am aware all of you may or may not have heard about indicator diagram, but after today's session, everyone is going to go back with a happy face. All right, now to start with, I have broken it down into like 2 parts. In the beginning, I'm going to talk a little bit about the theory, and it is about very short theory. I mean, like, little amount of theory, and just if that much amount of theory is there with you, okay, you can literally solve any question on indicator diagram. Is this clear? And then in the second part, what I have done, I have taken up a couple of questions, one sample problem, and two, three questions from the previous year's KVPY examinations on indicator diagram. All right, guys. So without any further delay now, we are going to start off because we have got less time in hand. Okay. So let's all keep calm, put on your seatbelts, and let's enjoy the heat. Okay. So guys, this equation out here, one of the most beautiful or the most sought after equation in your entire thermodynamics. What is it called? Yes, I see some of you already thinking. It's the first law of thermodynamics. Okay, where I need to understand what each of these terms mean. All right, what is the formula for finding out their magnitude, and what is the sign convention used for each one of them? Okay, students. Now, going ahead, heat, it is calculated as, I'm just going like, first with the formula that is going to give you the amount of heat required. It is given as nothing but NCP delta T or NCV delta T. It's specifically for a gas, and for gas we have two specific heat capacities. One is at constant pressure and the other one is at constant volume. So if it is at constant pressure, then I'm going to use this formula. All right. And if it is at constant volume, then students, I'm going to use this particular formula. Okay. Now, another convention is when is heat positive and when it is negative. If you provide heat to a system, then it is positive. And if you're extracting heat away from the system, then it is negative. Very simple. Second parameter, work done. How do we calculate work done? It's very simple. There's gas inside this container, and it is being fitted out here with a piston. Okay. Now, as it has been fitted out here with a piston, my dear students, now as this is exerting pressure on this piston out here, there has been force executed. That force is equals to nothing but pressure into area. All right. And as it exerts this force, it the piston goes up, let's say by a distance dx. So what is a small amount of work done? Small amount of work done is F into dx, my dear students. Okay. Then if I calculate it, force is nothing but pressure into area. So pressure into area into dx. So if you have to find out the total work done, guys, it is right. Absolutely correct, guys. So that is pressure into ADX. ADX is going to be nothing but dV. All right. And if you have to find out the total amount of work done, you integrate it. All right. So we get this formula out here. Integrated from V1 to V2. Initial volume to final volume. Okay. Now we are going to look at what is the sign convention used for work. If you look at the sign convention, it's very simple. If initially the volume is V1 and after that it has become V2, expansion is taking place. So volume is increased. Delta V is greater than 0, guys. If delta V is greater than 0, then work done is definitely what? It is positive. All right. So if expansion is taking place, my work done is positive. All right. Convention that we have for work done. The third, that is your internal energy. Now internal energy is what? See, internal energy is the sum total of the kinetic and the potential. Now potential energy for gas, if you would see, it is minimum. So it is basically, we are talking about what? We are talking about kinetic. So internal energy is the measure of the total kinetic energy of the gas. Okay. Now we know from the previous chapter that velocity is equals to, this is the root mean square velocity. It is nothing but equals to root over 3 RT by m. So velocity is directly proportional to the root of temperature. So if you increase the temperature, the velocity is going to increase. If you decrease the temperature, the velocity of the gas molecules is going to decrease. All right. That means if these velocities goes up and down, their kinetic energies are also going to go up and down. As a result of which, the internal energy is also going to change. That means I can say my internal energy is nothing but it's a function of time, my dear students. All right. Internal energy is a function of time. So, and it is given by the formula delta U is equals to NF by 2 R delta T. That means if my temperature increases, my internal energy is going to be positive change. It is going to increase. So the change is going to be positive. And if my temperature decreases, the internal energy is also going to decrease. All right, students. So that's like, the basic theory that you require actually. All right, and now we will just have a short glance at the sign convention for all these three parameters. Supply to the system, very good, positive. All right, take it away, negative. Expands, positive. Compress, negative. Temperature increases, positive. Delta U, temperature decreases, negative. So this is the basic sign convention that we are going to follow for all the questions which are related to my indicator diagram out here now. Now, before we can jump on to the questions, my dear students, I have a little discussion for internal energy, and then we will shift our focus to the questions of the previous years. Okay. Now, students, here one important point that you have to remember, that internal energy is a state variable. All right, it is a state variable. What does it mean? It only depends on the initial and the final position. That's it. It is independent of the path. Clear? And I know what? Simple thing. At point A, pressure is PAVA. At point B, it is PBVB. So here the temperature is going to be like TA, and here the temperature is going to be like TB. Right, students? Now you kind of take it through any path. The initial temperature and the final temperature for all these paths, I take it from A to B through three different processes. All right. But for all the three different processes, the change in temperature is the same. So, my dear students, delta U is going to be the same for all the three processes as I take the gas from state A to state B. So, let's say it is X. Okay, students. Now, second thing, remember how did we get our work done? Work done was nothing but equals to integration of P dV. All right. That means what? It is the area under the pressure volume graph, which is nothing but my indicator diagram. What is an indicator diagram, students? Indicator diagram is nothing but it's a graph on which on the y-axis we have got pressure and on the x-axis we have got volume. Okay, guys. So here it is just about your pressure and volume that is to be taken care of, and the area. See, it is going from here to here. All right. So whatever is the area under this particular curve, that is nothing but it is the work done, my dear students. Okay. So here I can see clearly through process 1, the area is the maximum. So the area is the maximum. So if I kind of take it as W1, W2, and W3, then my dear students, W1 will be greater than W2 will be greater than W3. Okay, and here delta Q, I can just put it as like say Q1, Q2, and Q3. All right, and then my Q1 is nothing but equals to X plus W1, and Q2 is X plus W2, and Q3 is X plus W3. I say, students, X is like, it's the same change in internal energy. So I can compare between what? I can compare between their heat flow also. I can say my Q1 is greater than Q2 is greater than Q3. All right. So what is the point that I need to remember out here? If the initial and the final points are the same, then whether you take it through any path, the change in internal energy, remember this point, the change in internal energy, students, is going to be the same. All right. Now, here, coming to the next point, this is the last slide that I have for Like, that is all you need to know. And once you're done with this, trust me, students, you can crack any question on indicator diagram. Okay, now the cyclic process, where let's say it starts from A and it takes a full cycle and it comes back to A. That is called as a cyclic process. Okay, so when I'm dealing with a cyclic process, students, if in the cycle I'm going clockwise, all right, if I'm going clockwise, then the work done is nothing but the area enclosed in this region. Okay, so it is just this area out here, and it is taken to be positive, students. And if it is anti-clockwise, then the work done is nothing but negative. Okay, guys. And remember, for cyclic process, for all cyclic process, okay, for all cyclic process, you have your change in internal energy equals to 0, my dear students. Okay, the change in the internal energy is equal to 0. So this is all the theory that you require, and based on that, this much theory, trust me, one question for your KVPY is sure shot. Okay, now let's just go to some basic question. Yes, one more thing. In the indicator diagram, if I have a line just parallel to, like, the pressure graph, the pressure axis, it's called as an isochoric process. Isochoric process, what is it? The volume remains constant. And for an isobaric pressure, isobaric process, the pressure remains constant. So delta P is equals to 0, students. For isothermal, my delta T is equals to 0. All right. And if it's an adiabatic process, then it is my delta Q, that is equals to 0, students. Okay. Now here, very easy question. Yes, this is not for KVPY. This is just a basic idea we like to test. Okay. Find the path along which the work done is the least. Okay, guys. Now here I have got two paths, ABC and AC. Now when I'm talking about ABC, students, when I am talking about this, I can break down the entire thing into two. That is along the path AB and then along the path BC. So along the path, what kind of a work, what kind of a process is this? It is a isochoric process. So my delta V is 0. If my delta V is 0, right, guys, work done is 0. Right, absolutely correct. Okay. So work done is nothing but the area under the BC curve. So which is like, all this region that you can talk about. Okay, all this region. And if I'm talking about, like, the work done for the process AC, then it is which region? Then it is only this region. So work done is list. Yes, all of you have already, like, some of you have already coming up with the answers out here as, like, the work done is least in the AC region. Okay, great, guys. Okay, fine. Let's take up another one. Now here, the internal energy of gas at state A, at state B is 20. So here it is 20. It is 20 joules out here, and at state A it is 10 joules. Clear? They have asked us, find the amount of heat supplied to the gas to go from A to B. So these are very basics. I'm going to take up after this the questions from KVPY. So from A to B, if you kind of go, what is it? It is a isochoric process. So work done is equals to what? 0. So the amount of heat supplied, delta Q, will be nothing but equals to your delta U. All right. So delta U is what? 20 minus 10. So that is nothing but equals to 10 joules. As simple and straight as that, guys. Okay. So here we take up my first question on KVPY, and let us just understand, okay, the importance of or how exactly we should go to solve these questions, guys. Okay, they require more of your thought process besides knowing the formulas as well. Okay, now this question had appeared in the year 2011, students. Okay, this is a question from 2011. Now if you see this, AB is a isobaric process, CA is a isochoric process, and BC is going to be what? It is nothing but it's a adiabatic, it's a isothermal process, guys, BC. They want us to find out, like, what is going to be the work done during one cycle, beginning and ending at A is going to be nearly what? Okay, now the challenge out here is what? It is not a triangle, like in the previous one. In the previous one, you had a triangle, half base into height you do, you get your answer. Okay, but first thing, what is going to be the work done in this case, positive or negative? Right, absolutely correct, guys. Okay, it is going to be negative because it is going in an anti-clockwise direction. Okay, second thing, if I see it, if I see this is the curve that I am having. All right, so this is, let's say, my isothermal process. Then, my dear students, if I kind of connect these 2 points, all right, what is going to be the area of the triangle ABC? Or say, like, this is C, this is A, and this is my B. All right. So the area is nothing but this region is how much? 500 minus 200. So that is like 300. All right. And this region, now the challenge out here is I don't know what is the volume out here at B. Now students, that is like, kind of interesting, because you see BC is a isothermal process. So my delta T is equal to 0. So students, it's what? It is nothing but it's a process in which the temperature is constant. That means my P1 V1 will be equal to P2 V2. All right, guys. That means if I put down the values out here, so say C is my 1 and B is my 2, then here it is going to be 500. Okay, 500 into 2 is equal to my P2. P2 is nothing but my B. That is nothing but 200. All right, into whatever is the volume. Clear? If you solve this, my V comes out to be how much? My V is nothing but equals to 5, my dear students. So here from 2 to 5, this is how much? 3 units. Okay, work done is going to be negative. That's what we have figured out already. And what is the area of this triangle ABC? What is the area of this triangle ABC? Okay, it is nothing but half base into height. If you do it, it comes to 450, my dear students. It comes to 450. Now the area of this region is definitely going to be less than 450 because it is inside it. Okay, so see how smartly they have tackled this particular solution. Okay, where you need to have that sense of thought behind the question. So this area is less than 450, and what is less than 450? 300 out here. Positive or negative? Negative. So option C is my answer. So this should take you more than even 1 minute to actually crack this question. Okay, so just knowing whatever theory we had, we can easily crack this particular question. Okay. Next. Now, this is one question in which it is again a very simple question. There are 3 processes they have mentioned. The 3 processes which has been mentioned out here, they are 1 to 2, that is nothing but your isothermal process. 2 to 3 is your isochoric process, guys, and 3 to 1 is adiabatic. Okay, excuse me. Now the total work done in this cycle is 10 joules. That is a total work done. So I can say that is the total work done means W12, all right, plus W23 plus W31. Okay, guys. So what is going to be the internal energy change for this entire cyclic process? 0, students, right? That means, can I say my total work done will be equals to the total amount of heat supplied, right? The total work done is going to be equal to the total amount of heat supplied out here. Now here, let me try and understand what is going to be the total amount of heat supplied. So total amount of heat supplied is Q12 plus Q23 plus Q31. All right, guys. Now, what is my Q12? Okay, Q12, if I have to calculate, that is what has been asked to us in the question actually. They have asked us what is the work done by the gas in the, no, that is also not. What is the heat added to the system in the isothermal process? Okay, that is what is Q12, that is what is my question given out here. Okay, then my dear students, see this question is kind of becoming very simple now. Okay, what is Q23 then? Q23 is, it's what I have to find out, and in the question it is given to me that the internal energy decreases by 20 joules in the isochoric process. So decreases, that means my delta U, okay, in 2-3 process is equal to minus 20. All right, students. Now, what is the work done in 2-3? Same logic we are applying again and again. 2-3, the work done is how much? 0. That means what is going to be Q23? Nothing but equals to minus 20. All right. Now, 3-1. 3-1 is what kind of a process? 3-1 is an adiabatic process. So what is the heat? Given or taken? Nothing. 0. So this is equals to 0. So this is going to give me how much? This is going to give me nothing but 10, my dear students. Okay. Then as a result of which, what is going to be my Q12? Yes, you get it right. Q12 is nothing but equals to 30 joules, my dear students. Okay. So you see, just the knowledge of a little amount of theory is going to give you a sure shot. Okay. Sure shot solution for one question at least. All right. Fine, guys. Let's take up another problem here. All right. And this is also a very interesting problem in your thermodynamics. Here, what we are doing is we have a, see, I mean, like, all of these are indicator diagram problems. Okay. So this is a circle. They are not shown the direction though, but just any direction is good enough. So let's take, like, this is the direction. I've kind of put it enlarged out here so that we can solve it better. They have asked us that where exactly during the entire process, during the entire cyclic process, is the temperature maximum? Okay. Or what is the maximum temperature? Like, where exactly, I don't know, but what is the maximum temperature? Now, just by looking at the data out here, I don't think so we will be able to solve it. Now, one thing you must have observed, students, like for all these questions, the analytical aspect for all the questions has to be there. Because if you do not analyze these questions and just, like, go with the formulas in mind, and yes, with all the formulas in mind, I'm just going to, like, solve these questions, boss, it's not going to happen. Okay, definitely not. Okay, so you need to keep in mind certain things, like you need to apply your minds to the questions. Okay. So let's see, this is, like, the question which came in the year 2015. This was a question from 2015, KVPY. All right. Now here, let's say this has been centered out here. So what are the coordinates of the center? 4, 4. 4, 4, my dear students. All right. Now here at this point, like, this point here is equivalent to this point here. All right. And this point here, these are the 2 points of my interest. Now, students, can you tell me what is going to be the temperature out here? Now, students, besides whatever the theory I told you, another equation is very, very important for your entire thermodynamics. That is the specifically the kinetic theory of gases and this laws of thermodynamics. That is PV equals to my nRT. All right. So this equation is kind of very, very important. So as per this, let's assume that it's like, talking about it's an ideal gas. They have mentioned in the question out here, and it's just 1 mole of gas that I am considering. Okay. Then T kind of can be written as PV upon your NR. All right. Let's take any more. It's okay, fine. Now, what are the coordinates of this point? The coordinates of this point is how much? 6, comma 4. So the temperature of this point is going to be how much? 24. Absolutely correct, guys. 24 upon NR. Okay. Similarly, the coordinates of this point will also be how much? 24 upon NR. All right. Now, here, somewhere in between them, my dear students, there is going to be a value greater than 24 by NR. Has to be, okay, because here, that, like, if you see, the value is increasing, okay, with respect to Y, and like, it's like, out here lessening in the volume part, but definitely there will be one point here, which is going to be like, more than 24. All right. Now, students, another thing that I can notice is any general point if I take, say it is at angle theta. All right, it is at angle theta. All right. Then, my dear students, what is going to be the coordinate of this general point? We know the radius. The radius is going to be how much? 2. All right. So, the general expression for pressure is going to be how much? So, the general expression for pressure is going to be 4 plus 2. This is the length for pressure. So, that is going to be 2 sine theta. And the general expression for volume is going to be how much? 4 plus 2 cos theta. Okay. So what is going to be the general expression for my temperature as a parameter of theta then? That is like, the product of these two. That is 4 plus 2 sine theta into 4 plus 2 cos theta, students. Okay. Divided by obviously NR. Now, what is the maximum value of this? The maximum value is going to be when both sine theta and cos theta is equals to 1. Okay. Simultaneously, they cannot be 1. First of all. Okay. Because for no value of theta, sine theta and cos theta, both are equal to 1. Okay. So, the maximum value of temperature is definitely like, it cannot be equals to whatever is this maximum value of this expression that it is. Okay. That is like, 36 upon NR. All right. It is cannot be that. And it is greater than 24 upon NR. Then, my dear students, what is there between 24 and 36? This. So, students, it is very, very important along with the question that you see, the choice which are given to you, they should be analyzed properly as well. And probably that is going to be one of the key areas where you would be able to have an edge over the others. Okay, guys. Now I'll take up the last question for today. I hope everyone's enjoyed so far in this session. I think there's some technical glitch for which this question actually didn't kind of surface up. No problem to that. I don't know why it didn't happen. But anyways, guys, the idea behind this question was, I can just discuss with you here. This question had also come in again the year 2015. All right. Let me just take a fresh slide and we'll kind of discuss it out here with you. This question had come in 2015. It was a very simple concept, but again, like, analytical in nature. So there's a graph here of not the regular PV, but volume versus temperature. Okay. And they had shown like, 3 isobars. These are the isobars having a pressure P3, P2, and P1, and they had asked us, like, there were various options asking us the relation between the pressures. Say P1 is less than P2, is less than P3, okay, and the second option was P1 is equal to P2 is equal to P3, or let's say it was P1 is greater than P2 is greater than P3, and let's say my fourth option is, like, D option is none of these. Okay, then students, it was a question which required your intervention of the ideal gas equation, PV equals to nRT. All right, so whatever we studied, and plus with that the ideal gas equation, I think, like, that helps in almost all the questions. Okay, now here if you see this V, I can write it as nothing but nR upon P into temperature. So this is of the equation y is equals to mx. All right, now here the slope is nothing but equals to, my dear students, this. All right, so if you see, the slope is inversely proportional to my pressure. Okay guys, my slope is inversely proportional to pressure, or I can say my pressure is inversely proportional to slope. So whichever has the greatest slope will have the least pressure. So out here, which has got the greatest slope? P3 has got the greatest slope. Okay, so P3 is going to be the least, and then will be your P2, and then is going to be maximum is P1. So option C was the right answer, students. So most of the questions, if you notice it, are kind of analytical in nature, and knowing exactly what has been kind of surfacing in previous years will give us a good exposure or a good amount of score for your KVPY examination, guys. Okay, so a wise decision and a wise choice of question is very, very important. Okay, now here, students, we have our Vedantu crash course, like, the master classes, the KVPY crash course. They have already kind of started, like, last week. I am the one who kind of is teaching for this KVPY sessions for the master classes, and we have a number of students, and all of the students were, like, so excited, and we did quite a number of questions on mechanics for the previous year's questions, and students were damn excited during that session. I invite and welcome you all to join our KVPY crash course session, which is already started. And students, the model of these entire course flow is going to be such that every week we are going to have one lecture that is scheduled on Friday, and based on the progress of the syllabus, we can even have, like, more. Totally depends on the demand of these students, because they are also, like, involved into multiple other activities and things like that. Okay, second thing, testing is very important, and for those, every week, like, in the first month, every week we are going to have, you're going to have part test and full test. So every week we are going to have, like, a part test, and then end of September we are going to have a full test. The frequency of the tests are going to increase in the month of October. Okay, and there is going to be proper analysis of all these questions. Like, just appearing for the test is not important. Once you've appeared for the test, we are going to do analysis of each of these tests, so that you know exactly how to solve these questions, what are the errors that you are making, okay, and so on and so forth. Okay, now students, the course is going to be live at the link which has been given out here. So vdnt.in/thermal, and you will get to meet me. And one of the best things that I can say is we'll be connected throughout, through not only during the sessions, but more importantly through the WhatsApp groups, wherein students have been posting so many doubts since last Friday, where we have been interacting throughout with them. Okay, so whenever you have a doubt, you just, like, click a photograph, put it to us, and then, like, me and my team would be working on those particular problems, get back to you with a solution with maximum to maximum 4 to 5 hours of time. Okay guys, Now, students, one thing that I would like to share with you that this course is pricing you currently at 20,000 rupees. All right. Now, the good news that I want to get for you, there is a lightning offer for all of you, which is valid for the next 4 hours, during which what is going to happen is in case you kind of making the making the move in the next 4 hours, you're going to get it for a very optimum rate of 10,000, which will ensure all your tests and lectures and revision and doubt solving and all that. Okay, guys. Fine, guys. So that's it for today, and we just had only 1 hour, but we will definitely would want to interact more with you guys. All right, online, definitely. That is how we generally do it. So all the online mediums, and it's been a pleasure to interact with you over this, just the starting of the weekend. So all of you have a great weekend ahead, guys, and enjoy your time at home. Happy studying, happy playing. Okay, and God bless you all. May God give you good health and mood to all of you to be strong. That is more important to before your KVPY and in advance your JEE mains examination, guys. Okay. So for any queries that you have with respect to today's session, you can always ping me or WhatsApp me at 830, that is my personal WhatsApp number, 8807045, students. So you can always get to me at this particular number, and if you have any queries, not just thermal, but with respect to other topics also, you can always get in touch with me. Or if you have any doubt in understanding any of the concepts which was there for today's session, you can always get in touch with me. Okay, guys. So that's it for today. God bless you all. Good night and take care.